So graph the relation. They literally just want you to put the coordinates on there. X and Y. X goes left and right. Y goes up and down. You have 4 points. You're going to plot those 4 points. All right. The domain and range, you can do it a couple ways. You could write it like a mapping diagram, right? And you could give me, 2 boxes here, domain and range, and write them that way. Or you can do it in set notation and just give me a list of numbers. A couple things, it needs to be least to greatest. All right, least to greatest. I did not count off that on your quiz if you didn't do least to greatest, but I'm telling you now it needs to be least to greatest. I did count off on your quiz if you gave me more than one. So if it appears twice, don't list it twice. Okay, so if you have a domain and it appears 2 times, just list it once. Or if you have a range and it appears 2 times, just list it once. All right. For mapping diagram is the next one. This one you have to either give me circles or rectangles, one or the other. And you have to label it. The biggest problem I actually saw on this on your quiz was that you did not label domain and range. So you do have to tell me which one is domain and which one is range here. All right, so you do have to label it. So if you miss some points and I wrote the names there, that's what I was trying to tell you. Once again, you're going to list it least to greatest and only list it once. And then this is the one where you draw the arrows from whatever numbers go from one to the other. Okay, that is your mapping diagram. For both 1 and 2, you have to tell me if it's a function. So if it is a one-to-one relationship, you're going to say, yes, it's a function. If you have multiple x's that lead to, or one x that leads to multiple y's rather, then you are going to tell me, no, it is not a function. And then the other one that we just described as far as how to tell if something's a function is the vertical line test. Vertical line test is really easy. If you can draw a line anywhere on it and cross it more than once, it is not a function. You'll see this first guy is a function. This is not a function. All right. And so those are the types of, is it a function? Yes or no? And then different ways that you can show me the same one. And I could combine all of them. I could say, plot these points, give me a mapping diagram, and then tell me whether it's a function. That could all be one question. So it may not necessarily be broken out like this. It may be all inclusive. I may tell you to map it. to draw the coordinates, to do a mapping diagram, and then tell me if it's a function as well. All right. So the first thing we did is we did evaluate. Evaluate literally means plug it in and solve. Plug it in and solve. So for this one, they have given us the function, and they've given us what we want to plug in. So you are going to say 6 cubed minus 4 times 6 squared. You're going to do order of operations, which tells you to do your exponents first, right? And then you would do your multiplication. And once you do this, right, then you're just going to do addition and subtraction. That is your answer. You don't have to do anything with this side of it. G of 6 equals that. That G of 6 is just literally saying, what am I plugging in? What is my output if I input a 6? My output is 72. All right. This one, I want the x-intercept, the y-intercept, the slope, and I also want you to graph it. Remember, once you have 2 points, you can graph it. So if you have the x-intercept and the y-intercept, plot those points and you can graph it. But when it's in standard form, all you have to do is some division. So if I want the x-intercept, then I take this 15 and I divide it by the number that's in front of the x. That's a 3. So my x-intercept here is going to be 5. If I want the y-intercept, then I'm going to take that 15 and I'm going to divide it by the number in front of the y, which is negative 5. So my y-intercept here is negative 3. And if I want the slope, I am going to do the opposite of what's in front of the x, so negative 3. And I am going to divide it by what is in front of the y, negative 5. So my slope here, you need to simplify, would be positive 3/5. To graph it, I really just need to take these 2 points and graph them. Remember, for x-intercept, your point is the 5 with a 0 for the y, and your y-intercept is a 0 for the x, and the -3 for the y. So to graph them, I can go to the +5 on the x-axis, the -3 on the y-axis, and then I can just connect those dots. Arrows at the end indicate it goes on infinitely, and that is my graph. For this set of questions, they want the slope-intercept form. You always want to make a note of what form they're asking for. Slope-intercept is y equals mx plus b. Now, it doesn't matter which method you use to get there, whether you use slope-intercept or point-slope, it doesn't matter, as long as your final answer is in y equals mx plus b. They actually handed you your m, so you really just need your b, okay? To find that, you can use your y and your x and plug everything in. Well, it helps to write it correctly. Your y and your x and plug it in. So -3 equals m, -3/4 x, that's 4, plus b. -3/4 times 4 is -3. When you add that 3 to both sides, you'll see that b equals 0. So your slope-intercept form for this one is just going to be y equals -3/4 x plus 0. And of course, you don't have to write plus 0 because anything plus 0 is just itself. Now, if you like point slope better, you can certainly do that. And you don't have to plug anything in. You can say y minus y1 equals m x minus x1. And then you can distribute and solve. And once again, you're going to, it helps, why am I writing that? I'm saying it and writing it. Again, when you distribute and solve and move the number over from that side, you're going to get the same problem. So you're going to distribute here, y plus 3 equals -3/4 x plus 3. Subtract that over. You get the same exact answer. It just doesn't matter which way you do it, whichever one you like better. If you solve for b, you have to plug them back in. If you do point slope, you're just going to end up with your answer when you're done. If you look at these two sets of problems, both of them gave you 2 points, okay? Both of them gave you 2 points. The first one wants it in slope-intercept, so you would do your y equals mx plus b. The second one wants it in standard form, so your final answer needs to be ax plus by equals c. For both of these, you need to solve for your slope because neither one of them gave you your slope. So you do also for both of these, you have to remember that your slope is subtract your x's over subtracting your y's. You do want to simplify your slope. So if it simplifies to a whole number, simplify it. If it reduces as a fraction, reduce it. If it's negative over a negative, make it a positive, okay? But both of these require that you find the slope. So if I were to find the slope here, -2 minus 0, that's my x's. -5 minus my 5's, that's my y's. I get -2 over -10, or my slope is 1/5. So now I have my m, and I can use either one of my x, y's and do exactly what I did on the problem before. I can do y equals mx plus b, right? I use my m. I just have to use one of those. I don't have to use both of them. All right, find your b, plug it in. Or you can use point slope. But this problem, 15 through 18, those are identical to the problems before it. You just have to find your slope first, okay? Now, the next one specifically wants it in standard form. So this one is a little bit different. You do have to find your slope. So for this one, you have to say -1 minus 5, that's my x's, over -5 minus 1. So -1 minus 5 is -6. -5 minus 1 is also -6. My slope here is 1. okay? Now, if you want to find slope-intercept form first, you can. You just have to move everything over. Either way, you're going to have to move your x's and y's to one side and your numbers to the other, okay? So whichever way you do this is fine. You can use point slope or you can use slope-intercept. If you use point slope, you just need one of your x's, one of your y's, 1 point here, and you need your slope. So you would say y minus y1 equals m, which is just 1x minus x1. You get y minus 5 equals x minus 1. In this case, you want to move your x's and y's to the left. So I'm going to subtract my x over here, negative x plus y, and I want to add my 5 to the other side. So I'm going to get equals negative 1 plus 5 is 4. The other thing you have to worry about is you cannot have fractions or a negative number in front of your x. All right, so in this case, I have a negative number in front of my x. So I have to take every single one of these and divide out that negative 1. So then the x becomes positive, the y becomes negative, and the 4 becomes negative. That is standard form, okay? If you did it the other way, let's say you did y equals mx plus b. Again, using this in my slope, I would have y, that's 5, equals m, that's 1, times x, that's 1 plus b. All right, you get 5 equals 1 plus b. B is going to equal 4. And so you have your y equals m, that's just 1x plus b, which is your 4. This is still not standard form. If you like solving this way better, that's fine, but you still have to move your x over, right? So I still have to move that x over. Negative x plus y equals 4, and I have to do the same thing over there that I did here because I still have a negative. So I would still have to divide everything by negative 1, and I would also get this. You will always get the same answer. Whether you use point slope or slope intercept, your final answer needs to be standard form. Ax plus by equals c. All right, so graphing absolute values. Absolute value is your v. Okay, so your absolute value is always going to look like this. And I don't think I gave you any with different slopes. So it's going to be always going up 1 over 1 on both sides, right? Just one slope, okay? It's just where on the graph is it going to be? So for this one, this is my standard. So this is what just y equals the absolute value of x would look like. That's if it has not moved. But the one that I want you to graph is actually moved. And so the inside tells you left and right. And it is opposite of what you would think. Positive moves you left, negative moves you right. The outside is up and down, and that follows exactly what you would think. Positive moves you up, negative moves you down. So basically this is saying, I need you to move this one over 4 places and down 2. And now your vertex for that absolute value is going to be there. And so when you have your absolute value shifted around, you're just going to draw it down here. And you're going to say, okay, so my absolute value is going to be down here. You still have your arrows, but that represents this equation. Now on your quiz, you don't have to draw the original. You don't have to draw this one. I'm just showing you what it looks like. You only have to draw this one right here, the moved one, okay? So you're taking this equation, this absolute value, you're moving it based on what it tells you to do right here. On the inside, it moves you left and right, opposite of what you would think. The outside moves you up and down, exactly how you would think it would. But the actual graph stays the same. It's still that V. Inequalities are graphed exactly how you would graph anything else. You graph the line or the absolute value. You decide if it's dashed or solid, and then you shade, okay? So you're going to graph the actual function exactly how you would graph it a couple pages ago, right? And then you're going to shade it. So for this first one, you can graph this using the intercepts. my x-intercept is going to be that 15 divided by the number in front of my x. So that's going to be positive 3 on the x-axis. My y-intercept is going to be that 15 divided by the number in front of my y. So that's going to be positive 5 on the y-axis. Now I just need to decide is this positive, if this is dashed or solid. So if I look at this, it's or equal to, which means it's going to be a solid line. And so I'm going to draw a solid line between those. And then I just have to decide if I'm shading above the line or below it. Now this is a greater than or equal to. And there is a positive in front of my y. If there's a positive in front of your y, that greater than equal to would not flip if you were to put it in slope-intercept form, because you're dividing by a positive, okay? So you can assume it's going to stay just like that. If there was a negative in front of my y, then when I put it in slope-intercept, it would flip that sign. And so you would actually do the opposite if there was a negative in front of your y, because dividing by a negative would flip your greater than less than, okay? So you can look at the number in front of the y and say it's positive, do what it tells me. It's negative, flip my greater than or less than. So for this one, I have a positive 3. I can do what it tells me, greater than. Greater than means I'm going to shade above. So wherever my y is, it's at a 5, so everything that would make my y bigger. That's this side of the graph. All right, for the next one, we're going to graph it just like we did my absolute value. I'm going to decide where my vertex is. Well, for this one, inside is saying negative 4. So I'm going to go right 4, and outside is plus 3. So I'm going to go up 3. So I'm going to start at 0, 0, and I'm going to go right 4 and up 3. And that's where my vertex is going to be, at the point 4, 3. I also look here, is it solid or is it dashed? Well, it's an or equal to. So this one is going to be a solid line. So I'm going to draw a solid line because I have the or equal to there. And then I have to decide, is it below that or above it? Well, the y is less than or equal to. So that means I am going to shade below it. All right, below the line. So it's everything on this side of the line that gets shaded. Word problems. Word problems, you're looking for x's and y's, or you're looking for a y-intercept and a slope. If you look at 35, they've given you a y-intercept, 1,000, and they've given you a slope, removing 50, negative 50x, right? But for this one, they have actually given you an x and a y. So we have an x and a y, so that's 2, 3. And they've given you an x and a y, that's 14, 15. Linear model, that means y equals mx plus b. We just did a y equals mx plus b given 2 points. Find your slope, right? Once you find your slope, put it in slope-intercept form using one of your points. So when you read the problem, don't get thrown off that there's lots of words. Look for xy, xy, or look for y-intercept and slope. That's what they're going to give you on a word problem that's a linear. How many leaves are there along 6 inches of the vine? Well, the way I wrote it, my inches is my y value. So once I have this right here, I can just plug in a y and solve for the missing variable. All right, so they've just asked for slope-intercept form. Then they've asked for plug in a y and tell me what happens. So if I do slope-intercept form, y's minus my x's, I'm going to get 12 over 12, which gives me a slope of 1. Then I'm going to plug it in with one of mine. I would probably use a smaller one. So y equals m x plus b. 3 equals 2 plus b. B equals 1. So my linear model here is just going to be y equals m. Well, that was 1. X plus b, which was also 1. All right. Once I have this, how many leaves are 6 inches? Well, my inches was my y value. So I'm just going to plug in a 6. 6 equals x plus 1. So x, which represents the leaves, should be 5 leaves. All right? That's a linear model. So it's really just asking for what you've already done. The next section covered distance and midpoint. So these are the formulas that you are going to have to know. Don't forget your distance formula is the square root of your x's when you subtract them in square, and then your y's when you subtract them in square. If it asks for exact value, then you're going to leave it as a square root. If it says, like these instructions, the nearest tenth, then you're going to put it in your calculator and get the answer rounded. So for this one, you would just label your x, y's, and then you're going to do your formula. Subtract your x's. Remember, it doesn't matter what order you subtract because you are squaring. Subtract your y's and square it. So you have -6 minus 1 is -7. And then 6 minus a -1 is also 7. For this point, you're just going to square those 7's. So you will get 49 plus 49, which will give you the square root of 98. Since they want this to nearest tenth, you need to put that into your calculator. And you will get this, which you will need to round. The nearest tenth would be this place, so you're going to look to the second one behind it. Since it is a 9, you would round up, and your answer here would be 9.9. For the midpoint, you're going to have to use your midpoint formula. This formula, you just add your x's and divide by 2, add your y's and divide by 2, and remember that answer is an xy point. So for this one, you would add your x's, add your y's, and then simplify. You have -10 plus -6 is -16 over 2. -4 plus -10 is -14 over 2. When you reduce those, you get -8 and -7, which would be your midpoint here. This last type of problem wants you to write the slope-intercept form of the equation of the perpendicular bisector of the line segment. So a couple things going on here. First of all, your answer needs to be in slope-intercept form, which is y equals mx plus b. They use the term perpendicular bisector. So you need to find the midpoint because the bisector goes through the midpoint. And you need to find the slope because in order for it to be perpendicular, you need to do the negative reciprocal of whatever this slope is. So, to find the slope, I will do the subtraction of my y's, 1 minus 4, over the subtraction of my x's. So 1 minus 4 is -3. -3 minus a -5 is +2. And since they want the perpendicular, then to get the slope that I am going to use, I will flip this and make this 2 over 3. And instead of negative, I will use positive. So this will be the slope that I am going to use. For the point that I am going to use, I need to do the midpoint. So I need to say my x is -3 plus -5 over 2 and 1 plus 4 over 2. So the point that I am going to use is -8 over 2 or -4 and 5 over 2. So I want a line that goes through this point and has a slope of 2/3. And so now I can just use my y equals mx plus b to solve. My y, that is 5/2. My m, that's 2/3. My x is -4, and then plus b. And so we will simplify this to solve for our b. 5/2 equals, when I multiply this, I get -8/3 plus b. Add your 8/3 to both sides. So my b is going to equal 5/2 plus 8/3. You will need a common denominator, which is 6. So multiply the top and bottom of this one by 3, the top and bottom of this one by 2. You will get 15/6 plus 16/6. Your b is going to be 31/6. So you know your m and you know your b. You just need to plug those in. Y equals mx plus your b. And that will be your answer.